An IQ test established some years ago was designed to have a mean score of 100. Research puts forward a theory that people are becoming more intelligent, so the mean's getting higher. She selects a random sample of 150, which I've got here, and I've got the results of that sample here. Carry a suitable hypothesis test at the 1% significance level. So, if we're doing a significance test, then I'm going to need my two hypotheses, H0 and H1. So, first hypothesis, it says basically the population mean is unchanged. So not the sample mean, but the population mean is unchanged. Mu is 100. The theory says that people are becoming more intelligent. The population, not equals, is going to be greater than 100. And so these are our two hypotheses that we're going to look at. Now, obviously it says, here we go, normally distributed. So we know that our sample is normally distributed. So if I take, for example, X to be our sample, I know that our sample normally distributed. Now, usually we use mu and sigma squared. However, we've got a sample here, and so we don't actually know what the population mean is, and we don't know what the population standard deviation is. So because it's the sample, I'm going to use X bar, and then I'm going to use, it was sigma over square root of n squared. Now you can write sigma squared over n, that's fine. I just write it like that because I like the standard deviation. I've explained before in all my videos. So I need to find out what X bar is, and I also need to find out what sigma is, but we don't have sigma. So actually what I'm going to use in here is I'm going to have to use S. Now if you remember, S is the unbiased estimator for this, and S, the formula for S, which I'll just move across a bit, that's sigma x squared minus nx bar squared all over n minus 1. Now, when we're dealing with a population, remember, we divide by n. So we'll find x bar, and x bar is going to be nice and simple. It is sigma x over n, so 15483 over 150, and that comes out to be 103.22. Next up, we're going to need to find S, and so S, remember, sigma x squared minus n x bar squared all over n minus 1 square rooted, and so that is 1631680 minus 150 times 10, need a bit more space on the screen, 103.22 all over n minus 1, so 150 minus 1, and then square rooted, and that particular value comes out as 15.0, and that's the 3SF. So I've now got my mean and my standard deviation, which I can then do, I can then look at my normal distribution. Now remember, we're dealing with those hypotheses, so we'll come back to those in a moment. Now, good, still in the clipboard. So here is my normal distribution curve, and we'll do it in light blue as our originals. So our original values were a mean of 100, a standard deviation of, can't even remember, what was the standard deviation? Oh, we've just done it, and it wasn't sigma, so mean of 100 and a standard deviation of 15. No, not 15, it's 15, here we go. So S over square root of n, because we're dealing with a distribution of sample means, so that's going to be 15 over the square root of 150. And then we're looking at the specific value at 103.22. Now, as I've said before in my previous videos, I don't tend to like to use these particular values. I prefer to use our standardized score values, primarily because we have tables for them, it's nice and easy, and I like to find my critical value quite easily. So I need my standardized score for 103.22, so it's that minus the mean over our standard deviation, which is 15 over the square root of 150, And so that comes out to be, where's my little, there's numbers, so 2.629. 2.629. And so that is 2.629. Now, the question asked us for a 1% significance level. So, as I've said before, I like to look at that up in my tables. 1% would mean 99% on this side, because it's 1% on this side. And on my tables, and here are my tables, inverse function, so 0, 0, 0, so I just need the 99 on this side. And there's my value, 2.326. So, I know that my critical value is going to be somewhere along here. So that's 2.326, i.e. this area here is my 1%, and this is H1 accept. This area here on the other side, which I'll do in pink, this area is H0 accept. And so, effectively, we can now do our conclusion. So our information then says, and we summarize, H0 rejected, H1 accepted, and again we put our conclusion. So there is evidence at the 1% significance level to support the view that scores on the IQ test are now higher, i.e. the mean has increased of the parent population.